All right, we're back one more time here with our atomic structure, okay? So we're going to think about our nucleus here for a second, right? Our nucleus, we've got our protons and our neutrons. The number of protons, this one right here, this is going to be what determines our element. Our neutrons, right, tells us really what isotope we have. Okay, so protons tells us which element we have, and then when we add up our protons and neutrons, right, we add those two together, that tells us how many, or what our AMU really is, and that tells us our isotope. Okay, so our electron cloud, right, what we're going to do is we're going to have an order that we fill it from, right? We start with the lowest energy electrons, and we're going to use our tree. So 1s, 2s, 2p. I'm going to fill this all the way up, and we're going to see how we fill it. Okay, so this is really our Christmas tree of electron shells, right? We're in any s orbital, we can get up to 2 electrons. In any p orbital, we can get up to 6 electrons. D orbital, we can get up to 10, and our f, we can get up to 14 electrons. Okay, and our order of filling, we're going to do our 1s first, and then we run out here, right? We hit the wall. So then we got to go start back at the beginning, and we go 2s, and we hit the wall again, and then we would go over to the 2p, and then we hit the 3s. So, right, this is going to be our order here if we follow our arrows, right? We go along diagonal. Okay, so if we have just 2 electrons, we can fit them both into the 1s. If we've got, say, 10 electrons, right, we fit 2 into the 1s. Our first 2 would go there, and we put them up at the top. And then we go fill in the 2s. Okay, so we get the 2s. We can fit 2 more electrons in there. That's up to 4 electrons now. If we've got 10 electrons, we go over, right, we hit the 2p. We can put 6 electrons in there. There's all 10 of them. Okay? If we add 1 more electron, it's got to go up into the 3s1. Okay? So we keep on filling in if we need, right? We would go 3p, and then we would go hit the 4s. Then we would go back to our 3d, the 4p, and then the 5s. And then the 4d, the 5p, the 6s, and then we go 4f, 5d, 6p, 7s, and then our last section here, 5f, 6d, 7p, and we really kind of end there. That's as many as we've been able to see. Okay? If we also look at our periodic table, we can see that that same structure, the order of filling, matches the structure of our periodic table. Okay? So, if we have that, you can see that I started filling in my electron. This is my electron configuration. We can use our abbreviated electron configuration, and if I look here, right, all of this is the exact same as the electron configuration for neon, and then I can just say 3s1, right? That's my noble gas configuration, okay? I can also use orbital diagrams, okay? So let's get this all lined up here. Okay, so if I have an orbital diagram, right, I'm going to say again that I have 1s2, whoops, I'm over onto the side. 1s2, 2s2, 2p6, 3s1. Okay? My orbital diagram, it's our arrows. My 1s has one orbital, and I can fit 2 electrons in there. My 2s, one orbital, I can fit 2 electrons in there. My 2p, right, because I have 6 electrons, that means that I must have 3 orbitals, right? P orbitals, we have 3 different types, and what we would do is we would fill in 1 electron into each first, right? We spread them out as much as we can, and then, oh, we still have to fill them, so we're going to pair them up, okay? So there's my 2p, and then my 3s, I only have 1 electron, so that's my 1 electron that goes up there, okay? So again, all I'm doing is that I'm going to use the arrows. I'm going to show how my electrons are paired or unpaired. And if they're unpaired, they would be magnetic, okay? So if I ended up with something, say like nitrogen, right? Nitrogen has 7 electrons. So it would go the 1s, it would have the 2s filled, and then I would go to my 2p, where I've got 3 orbitals. I would put 1 into each, and it would be, if I had just a single nitrogen atom, it would be magnetic, okay? So I fill them all up, starting from the lowest energy, same as I did with my electron configuration, and I'm going to start filling them up, filling them up, filling them up until I have them all. If I have 3 orbitals or 5 orbitals or 7 orbitals, I fill 1 electron into each, right? Same as over here, 1 electron into each, and then if I have to, I start pairing them, okay? So what is photoelectron spectroscopy? Photoelectron spectroscopy is basically just an experimental technique that really tells us about our orbital diagram. Photoelectron spectroscopy, we're going to say that it's PES, is really what tells us that our electrons, right, we have this splitting of orbitals where we have the 2s orbital is slightly lower in energy than the 2p orbital, okay? So it's going to show us really how strongly the electrons are held by the nucleus, okay? So this is where we're going to pause because this is a really important concept.